Everyone, my name is Rakshita. I'm pursuing my final year degree from the Department of Electronics and Communication Engineering from Sri Venkateswara College of Engineering, Bangalore. Today I will be discussing about the subject called real-time system, and the subject code is 18EC731. Today in this video I'll be discussing about real-time systems in industry. So without any further delay, let's get into our video now. So now let's see what is real-time system. A real-time operating system is an OS that guarantees real-time application, a certain capability within a specified deadline. RTOS are designed for critical systems and for devices like microcontrollers that are timing specific. RTOS processing time requirements are measured in milliseconds. So this is a block diagram of real-time system. Here we have sensor, which is an input, and sensor is an input for the conditioning unit, and from conditional unit it is given to the input interface. From input interface it is given to an real-time system. From real-time system it is given to an output interface. From output interface to the output conditioning unit, and it is given to the actuators. In real-time system we have three types. The first one is hard-time real-time operating system, and the second one is soft real-time operating system, and the third one is firm real-time operating system. So now let's see the application of real-time system. There are many applications. I will be discussing about a few applications in this video. The first application is the medical application. A few examples on medical application of real-time systems are robots and MRI scans, radiation therapy equipments, besides monitor and computerized axial tomography, etc. So now let us see an example. Robot used in recovery of displaced radioactive material. Robots that have become very popular nowadays and being used in a wide variety of medical application. An application that we discuss here is a robot used in retrieving displaced radioactive materials. Radioactive materials such as cobalt and radium are used for treatment of cancer. At times during treatment, the radioactive cobalt gets dislocated and falls down. Since human beings cannot come near a radioactive material, a robot is used to restore the radioactive materials to its proper position. The robot has to sense its environment frequently and based on this information plan its path. The real-time constraints on the path planning task of robot is that unless it plans the path fast enough after an obstacle is detected, it may collide with it. The time constraint involved here of the order of few milliseconds. So now we shall see the second application, that is in automotive and transportation. Like transportation is very important in our daily life. We'll be discussing about an MPFI system, is an automotive engine control system. It is a real-time system that controls the rate of fuel injection and allows the engine to operate at its optimal efficiency. In order or in older models of car, a device called carburetor was used to control the fuel injection rate to the mechanical engine. It was the responsibility of the carburetor to vary the fuel injection rate depending on the current speed of the vehicle and the desired acceleration. In MPFI engines, the precise fuel injection rate at each injection point is determined by a computer. An EPFI system injects fuel into individual cylinders, resulting in better power balance among the cylinders as well as higher output from each one along with a faster response. The processor primarily controls the ignition timing and the quality of the fuel to be injected. The latter is achieved by controlling the duration for which the injector valve is open. The action of the processor are determined by the data cleansed from sensors located at over the engine. The sensors constantly monitor the ambient temperature, the engine coolant temperature, the exhaust temperature, emission gas contents, engine RPM, vehicle road speed, etc. The next application is Internet and multimedia application. It is important to use real-time system in multimedia and internet application include video conferencing and multimedia multicast, internet routers and switches. Now we shall be discussing about the video conferencing. In video conferencing application, video and audio signals are generated by cameras and microphones respectively. The data are sampled at a certain pre-specified frame rate. These are then compressed and sent as packets to the receiver over a network. At the receiver end, packets are ordered, decompressed, and then played. The time constraint at the receiver end is that the receiver must process and play the received frames at a predetermined constant rate. Thus, if 30 frames are to be shown every minute, once a frame playout is completed, the next frame must be played within 2 seconds. So we will be discussing about the challenges faced by the real-time system in this slide. Real-time systems are designed to process data as soon as it is generated and provide immediate feedback. Building a system comes with its own set of challenges. There are some of the common challenges faced in real-time systems. It might be cost, durability, complexity, scalability, security. So let's discuss one by one. The first is the cost. Real-time systems can be expensive to build and maintain, especially when they require specialized hardware or software. Data quality. Real-time systems on accurate and reliable data to function properly. Poor data quality can lead to incorrect results and discussions. The next is the complexity. Real-time systems can be complex or difficult to design, implement and test. Next is the scalability. Real-time systems must be able to handle large volumes of data and uses without sacrificing performance or reliability. Next is the security. Real-time systems must be secure to protect sensitive data from unauthorized person. So to overcome these challenges, organization must invest in the right technology infrastructure. They must also have a clear understanding of their business requirement and goals. So thank you for watching my video. Please do like the video, share and subscribe to my channel. Thank you all.